Okay, let's do some examples with the ratio test. So pick some out here. Let's look at the summation n equals 1 to infinity of k times 2/3 raised to the k. And that'd have to be a k if I'm doing that. So, what do you think happens to this guy? So I've got this series. Let me go ahead and make these all n's because we've been talking about n's all day long. I just copied this one from the book and it had k's in it. So you got an n here, and an n here. Okay, now looking at this, do you think it's going to converge or not? I'm not really sure. Now, if the n wasn't there, that would be a geometric series, and 2/3 is less than 1, so this would be a geometric series that would converge. Now, if this number wasn't n, if that was like a 3, it'd be real easy. Look at that guy. What's the first term? First, it's going to be a 1 here, so that'd be a 2. So this would go to 2, 1 over 1 minus 2/3, and that'd be the answer. If that was a 2, but that's not a, if that was a 3, but that's not a 3, that's something that's moving. That's an n, and this guy's growing all the time. It's not a constant. So that's not going to be the answer. I'll probably never know what the real answer is. I'll just be able to determine whether I think this guy converges. Does it converge? Or does it diverge? I don't know. So let's look at it. Now again, I don't know what to do. So my favorite test is the ratio test. So what I'm going to do, I'm going to look at the limit as n goes to infinity of an plus 1 over an in absolute values. So what's that going to be for this guy? That's going to be the limit. N goes to infinity. Well, everything in there is positive, so the absolute values don't mean anything. So, but don't get careless and don't use absolute values. In this case, everything's positive, so they don't need them. Let's look at what is an plus 1. That means every place you got an n, put an n plus 1. So this is going to be n plus 1. Use parentheses liberally so you don't screw up. N plus 1 times 2/3 raised to the n plus 1 over n 2/3 to the n. Now I got to look at this thing and see what happens. I'm going to have to do a little cleaning up on this guy first before I can figure it out. A couple things to talk about. How many 2/3 do I have? I got n plus 1, and I got n 2/3 down here. So I'm going to rewrite this guy. Sorry, always coughing to your elbow. That's what I learned off of the internet. Equals, so let's see what this thing equals to. It's going to become the limit n goes to infinity of, I got n plus 1 times, now I've got 2/3 times to the 1 power, and I got 2/3 to the n power, and that'd be 2/3 to n plus 1 power divided by n times 2/3 to the n power. Now all these guys are multiplied. Therefore, this thing right here is a big fat 1. So this thing equals the limit n goes to infinity of, that's gone, and I got 2/3 n plus 1 over n. Now what happens, go ahead and be careful here and do all the stuff you're supposed to. I'll multiply this by 1 over n, multiply this by 1 over n. What I really do, I multiply by 1, so this is going to equal the limit n goes to infinity of, and that's going to be 2/3. Multiply that in, you're going to get a 1 plus 1 over n. Multiply this in, you're going to get a 1. So as n goes to infinity, that's going to go to 0. So this is going to equal, that's going to go to 0, 1 over 1 times 2/3. So this is going to equal 2/3. Okay, so I did this ratio. When I worked it all the way through, I found it equals 2/3. Now we're going to look at it. I got to look at what this guy is. If it's less than 1, equal to 1, or bigger than 1. This guy's less than 1. If it's less than 1, it says that this guy right here is absolutely convergent. So my original series that I was looking at is absolutely convergent. And we wouldn't care about the absolute value part here because everything's positive anyway. Okay, so there's how you use the ratio test. Let's do another example. Okay. suppose I got summation n equals 1 to infinity, and I got a 25 to the n over n factorial. Okay, now, do we think this guy converges or diverges? I don't know. It's all positive, so the absolute values aren't going to matter again in this case. But I don't know. I got to see which is. I don't even know if the insides are going to 0 in this case. Now, who's growing faster? 25 to the n. That's a screaming fast function. Or is n factorial going faster? That's a screaming fast function too. We're fixing to find out who's faster. Okay, so I'm not quite sure what to do. So I'm going to pull out the ratio test. Now, every time I see a factorial inside a series, I'm going to use the ratio test. Like the integral test is kind of hard to take an integral of a factorial. But factorials work really nicely with the ratio test. Okay, so let's look at the limit. N goes to infinity, absolute value of a to the n plus 1 over a n. So a n plus 1 over a n. And again, I don't need the absolute values because these guys are all positive. But don't get careless and don't use absolute values because sometimes they're not all positive. So let's look at this. What is a n plus 1? Okay, well that's going to be 25, use parentheses, to the n plus 1 over n plus 1 factorial. Then I got to divide that by 25 to the n over n factorial. And again, it's in absolute values, but everything's positive, so I can drop the absolute values. Okay, so this is going to equal the limit. N, we drop it a little bit because we're running into that guy. Limit n goes to infinity. And now I'm going to clean this up a little bit. What have I got here? I got 25 to the n plus 1, so I can rewrite that as 25 and then 25 times 25 raised to the n power. Okay, and that's over n plus 1 factorial. I'll get to that in a second. Now I'm going to flip the bottom. It's a 4-story fraction. Here's my big divider. I'm going to flip it, so I'm going to get n factorial on top. And now on the bottom, I'm going to have 25 to the n. And now I got n plus 1 factorial. Okay, now it's easy. Everybody's multiplied, so I can be a little careless here. So this thing right here, you got plus signs in here. You can't be canceling stuff off top and bottom. Remember your algebra. That's going to turn into a 1. Okay, now, so let's rewrite this guy. I'm going to have the limit. N goes to infinity. That disappeared. I'm going to have a 25 on top. And I'm going to have a times an n factorial on top. Now let's look. The only thing on the bottom is n plus 1 factorial. But what's n plus 1 factorial? Well, what's 5 factorial? 5 factorial is equal to 5, 4, 3, 2, 1, right? All multiplied. Well, n factorial would just be n plus 1 factorial would be n plus 1 times n minus 1 times n minus 2. So that's really just n factorial. So n plus 1 factorial is n plus 1 times n factorial. Well, now look at the n factorials. They cancel, and I got 1. Okay? So what's going to happen here? This guy's going to turn into a limit 25 over n plus 1. And this equals, as n goes to infinity, and that equals 0. Okay? Now, so it equals 0. Since 0 is a number and it's less than 1, this guy is less than 1. Now, remember on the ratio test, we had to go to something, had to go to a number that was bigger than 1. We had to go to a number, and the number had to be, had to go to a number, and the number had to be bigger than 0. If it went to 0, the ratio was the limit, not the ratio test, the limit comparison test. We went to a number, and that number couldn't be 0. Here it's okay. You're going to a number, went to a number, that number was 0. That's not bad here. Is 0 less than 1? Yes, 0 is less than 1. So what can I say? This series right here is absolutely convergent. Okay. And again, you don't need the absolute because it's all positive anyway, though it kind of looks stupid. But this series does converge. Again, let me make a point here because I haven't said it wrong. When you're doing the limit comparison test, that limit has to go to a number, and that number has to be bigger than 0. And then it tells you something about this series. Here, I'm doing the ratio test, and I'm looking at a sequence taken from the series. If this ratio goes to a number, happens to go to 0, that's okay, because 0 is less than 1 in this case, and that means the thing converges. Okay, let's do another test, another example. Okay, so this guy converged. And anytime you see factorials, you want to use the ratio test because it works really good with factorials like we saw here. Okay, now here's a squirrely one. I think you had this for homework, but you didn't have this big hammer to make this guy work out. And we got n factorial over n to the n. Okay, and the last one, what we had 25 to the n over n factorial, and this guy converged. Since this guy converged, this thing right here had to go to 0. So that means that this grows a lot faster than the exponential function grows. So exponentials are slower than factorials. But now let's look at this one. I got a factorial on top, and I got n to the n. This is not an exponential function. This is a the base is growing and the power is growing. On an exponential function, you got a constant base and the power grows. So this is a really screaming fast function, and that's a screaming fast function. And who wins? Who goes? Does this thing go to 0? If it does go to 0, does it converge? I'm not sure. Let's see. If this thing does converge, it means that this thing right here was faster. So let's look at it. I don't know what to do. I'll look at it, see a factorial. I'm going to use the ratio test. So let's look at the limit as n goes to infinity of an plus 1 over an in absolute values. And again, sorry for this. I didn't pick out an example that has some negative numbers in it. So this is going to be, what happens when I put in n plus 1? That's going to be n plus 1 factorial over n plus 1 raised to the n plus 1. Okay, that's the top. And the bottom is going to be n factorial over n to the n. Now you have to do some algebra on this guy. Okay, I'm going to break this guy up. So that's going to be the limit. Again, drop it a little bit. That's going to be the limit. N goes to infinity. This thing right here, that's going to turn into n plus 1 times n factorial. Because this would be n plus 1 times n minus 1 times n minus 2. So I can just write it as n plus 1 and then n factorial. Now bottom, I can rewrite the bottom of this guy as n plus 1, got one of those times n plus 1 to the n. And now I'm going to take this and flip it, and I'm going to get n to the n over n factorial. Now, notice everybody's multiplied, so I'm going to start canceling things. I've got an n factorial on top, n factorial on bottom. This one will cancel that one and make a 1. I've got an n plus 1 on top and an n plus 1 on bottom. So these two guys are going to cancel. And I'm going to be left with the limit n goes to infinity. What am I left with? I got n to the n over n plus 1 to the n. Okay, all I got is this thing over that thing. Okay, I'm going to erase this, and I'm going to rewrite that a little better and work with it here. So I got the limit is n goes to infinity, and I've got n to the n over n plus 1 to the n. Now I can rewrite that as the limit n goes to infinity of n over n plus 1 to the n. Okay, now, what's happening? Let's look at the inside. Okay, the inside, as n goes to infinity, where's this going to? The n goes to infinity, I can multiply top and bottom by 1 over n, that'll be a 1, that'll be a 1. And so I got 1 over 1, and that'll be 1 over n, so that will go to 0. So the inside's going to 1. Inside's going to 1. And the power's going where? The power's going to infinity. So I'm gonna look at this guy and I'm gonna go, crap, this thing looks like it's got the form of 1 to the infinity. Now, is that one of the forms we can deal with? Remember back on the L'Hopital's rule. If you got 1 to infinity, is that an undeterminate form? The inside's trying to pull to 1. This guy, the higher power, if this number is less than 1, it's going to drive it to 0. If this number is bigger than 1 and going to 1, it's going to drive it to infinity. These guys are all less than 1 and are approaching 1 from the bottom. So this infinity is going to try to drive it to 0. The insides are trying to pull it to 1. So how do I deal with this? I'm going to have to do some fancy footwork here. So what I'm going to do, I'm going to say y is equal to x over x plus 1 to the x. Okay, I turned it to a function, a continuous function. Okay, so now I'm going to take the ln of y is equal to the ln of x plus 1 to the x. Now this is an ln, so I can do with that x, I can pull it out front. So I'll put me an x here. So I have it written this way. Now, let's look at the limit as x goes to infinity here. That's going to be infinity, and that's going to be 1. So as x goes to infinity, that's going to be a 1. That's going to be infinity. ln of 1 is 0 and infinity. So this guy, when I do the limit, may not be sloppy here. When I do the limit, as x goes to infinity of x ln x over x plus 1, that's got the form infinity times 0. Okay, so what am I going to do? I got to take one of them underneath. I don't want to take that underneath because I want to take the derivative of that. I'm going to take this guy underneath because that'd be easier to take the derivative of. So I don't want to get lost. I got a bunch of stuff going on here and a little bitty board. So let's see. What can I erase? I don't want to lose what I got here because I'm going to have to undo a lot of stuff that I did. So let's look at, so I got the limit. X goes to infinity of x over x plus 1 ln of that. And I'm going to drop this underneath, so that's going to be x to the minus 1. Okay, so now this is the form. That's going to be 0. That's 1 over infinity, so that's going to be 0. It's going to be form infinity over infinity. Or 0 over 0. You know what I mean? So that's going to be the form 0 over 0. So now I can use L'Hopital. So by L'Hopital, I'm going to have to take the derivative of this thing, and what can I erase without losing what I really wanted? So let's see. This is my definition. This is where I did the y, so let's erase this line right here. Okay, so take the derivative of this. What's the derivative of this going to be? Derivative of the top. So by L'Hopital's rule, this is going to equal the limit x goes to infinity. Derivative of this guy is going to be 1 over this. So that's going to be 1 over, it's just going to flip it, x plus 1 over x. And I can multiply by the derivative of the inside. The inside is going to be a little bit of a pain in the butt. Okay, derivative of the inside, you have to take derivative of the top, which is 1 times the bottom, which is x plus 1. So derivative of the top times the bottom plus the top minus the top times the derivative of the bottom, which is 1 over the bottom squared. And then all that is over this guy squared. Sorry, all that's over, what did I do? Derivative of the top, 1, wait. So, derivative of the top is 1 times the bottom, minus the top, derivative of the bottom, and the bottom squared. And now I've got to take, that was just the derivative of this guy. Now I've got to take the derivative of the bottom of this thing. And so the whole thing's going to be over. What's the derivative of this? Bring down your negative 1, so it's going to be minus x to the minus 2. Okay. Now I'm going to erase this, and let's see if we can figure what this thing looks like. It's getting kind of nasty. So what have I got? This looks, so that's, I got on top, so I have the limit. Sorry, this one's a little longer than I thought it was going to be. Infinity, and I've got x plus 1 over x, and this is going to be times x plus 1, this, minus x over x plus 1 squared, and all that's over a negative 1 over x squared. Okay, now I'm going to write this up here. I'm going to need some room. Y equals x over x plus 1 to the x. And so now I've got to clean all this crap up, and it's getting kind of complicated. So these x's kill each other, and I got a 1 here, and this x plus 1 over that x plus 1 will kill that one. And so I got a 1 over, and x plus 1 actually killed the square, x plus 1. Make sure I did that right. So kill this, that just turned into a 1, and I got an x plus 1, and I still have an x here. And now I got this guy. I got to take that guy and flip it, had a negative on it, so I'm going to get a negative x squared over 1. I got to take the limit as x goes to infinity. Now so look at this. This equals the limit x goes to infinity. What happens here? I got an x on top, x squared on top, and so I'm going to get a minus x over x plus 1. Okay, now where is this going? This is going, as x goes to infinity, this is going to equal a minus 1. Okay, now that's not really where it went to. We said y was equal to this, and remember we did the ln of both sides. And we did the ln of both sides, so the real limit on this guy is what? The real limit of this whole thing, and again, sorry I'm having to do it with a little bit bored. It's annoying to me, but we'll do the best we can until we get over this crisis. So this went to a negative 1, so the real limit is e to the negative 1. So when I do all of this, I hope, and it did all of this stuff right here, I ended up with e to the negative 1, which equals 1 over e. So unless I screwed up somewhere in here, the final answer to this thing is 1 over e. Now 1 over e, is that bigger than 0 or less than 0? I think that's less than 0 because that number is about 3, so it's about a third. So that's less than, not less than 0, less than 1. That's less than 1. If that's less than 1, then this guy converges absolutely. So this guy is absolutely convergent. Okay, so that means this is a faster function than that one. Okay, sorry that one's kind of convoluted and really bad to do on a little bitty board. I try to pick problems that are small so I can do on this board. That one got a little out of hand. So remember, when you're doing this, sometimes you run into stuff and you have to go back to Cal 1 and do your stuff with the L'Hopital's rule and some of these weird forms. Okay, got one more I want to do before I'll let you go. Let's look at the summation n equals 1 to infinity of a minus 1 to the n over 5n plus 1. It's a 5, not an s. Okay, so let's use the ratio test on this guy. So I'm going to look at the limit. N goes to infinity of a n plus 1 over a n in absolute value. So that's going to be the limit. N goes to infinity. I'm dropping absolute value bar, so it's going to kill that negative. All this stuff's positive. So that's going to be the limit of, I'll go ahead and put the negatives in first. so I don't confuse you, minus 1 to the n plus 1 over 5 times n plus 1 plus 1 over a minus 1 to the n over 5 n plus 1. Okay, again, these don't matter because I got absolute value bars, so the negative signs don't matter, so I can drop these. Those will just be 1s. So this is going to be the limit. N goes to infinity of 1 over, I'm going to multiply this out, that's going to be 5n plus 5 plus 1. And then this is going to just be 1, and I'm going to flip that guy, so that's going to be 5n plus 1 over 1. Okay, now let's look at this one more time. So that's going to be a limit. N goes to infinity of 5n plus 1, and this is going to be 5n plus 6. Where do you think this is going to go? This guy's going to go to 1, but let's go ahead and be meticulous. So I multiply top and bottom by 1 over n. And when I do that, I'm going to get the limit. N goes to infinity of 5n over n is going to turn into 5, and that's going to turn into 1 over n, and this is going to turn into 5, and this is going to turn into 6 over n. So as n goes to infinity, that's going to 0, that's going to 0, so I'm 5 over 5, so this equals 1. Okay, so I did the ratio test and I got a 1. What does that tell me? Doesn't tell me squat. Ratio test didn't do any good. It was a good test on your algebra skills. Down with the 1. The ratio test didn't tell me anything, so I can't use the ratio test. I gotta go back and use something else. Well, it really was kind of stupid we even did anything on this one. Alternating series, right? If I ignore the negative part, just look at 1 over this guy's n goes infinity, this thing's getting smaller and smaller. 1 over 5 to the n as n gets bigger, gets smaller and smaller. So this is decreasing, going to 0, decreasing, and it's alternating. So I know this guy converges, but it doesn't converge by the ratio test, it converges by the alternating series test. Okay, start with the one problem. Hopefully you can go through my mess and figure out what we did on that third problem, and I'll give you homework set and have a good day.